Hi, I'm Ashley, and I'm going to explain the experiment of a ball bouncing. The rebound height of the ball will never be as tall as the drop height of 1 meter because some of the energy in this system becomes heat and sound energy. As more of the energy is changed to heat and sound, the ball will eventually come to stop. In ball drop, energy being transformed, although the total amount of energy remains the same, the potential energy is given to the ball, specifically gravitational potential energy. As the ball falls toward the ground, its gravitational potential energy is transformed into kinetic energy. Gravitational potential energy, GPE, is the energy gained by an object as its height above the ground level increases. The formula is GPE equals to height multiplying by weight. The kinetic energy of an object is the energy it possesses due to its motion. It will be continue increasing as ball gains momentum until it finally collides with the surface. A ball dropping is an example of an elastic collision where part of the kinetic energy is changed to some other from where colliding with the surface. After the ball rebounds, the elastic potential energy is transformed into kinetic energy, but it will never possess as much kinetic energy as during its original fall. The ball will never be able to rebound to its original height. This is because some of the original kinetic energy has been transformed into sound, friction, and deformation of the ball. Our hypothesis. When the ball is held at its highest point, it has potential energy, specifically gravitational potential energy. When the ball is falling, it has kinetic energy. It has the most kinetic energy at the very end of its descent when it's moving the fastest, without other forces such as air resistance. The ball is still not be able to bounce to its original drop height. Because of this energy transfers, the ball will never have as much kinetic energy as it originally had, because when you drop the ball from certain height, the potential difference is at its extreme point. When the ball hits the ground, the potential energy naturally decreases, which stops the ball from bouncing after a while. Here we have our proposed and rich question. Why and when does a ball stop bouncing, and how much energy is lost when a ball is bounced? Our variables are dependent, that is the time and the energy, independent, that is height and the weight. The bouncing ball stops bouncing because of mainly three factors: friction, gravity, and decreasing the potential energy. And our control data is ball and the ground. When impacting the ground, energy is also lost because of the elasticity of the surface as well as the sound and heat produced by the impact. Our materials are ball, flat surface, tracker, a video camera, laptop, notebook, and something to record our data. Our method. When the ball hits the ground, it is pressed with force of gravity and other forces that was started on it. Some of energy is converted into potential energy as the shape of the ball and the surface change. The potential energy is realized by the stress the object will produce to return its previous shape. We here also have our formula that is EP plus EK equals to EP plus EK plus P. EP is our potential energy, EK is our kinetic energy, and P is the loss. Each formula has a principal variable that characteristic generates its type of energy, velocity, position, and losses. So the EP is equal to M, that is the mass, G, that is the gravity, and H, that is the height. And EK is equal to half mv squared, where m is mass and v is the velocity. So the formula changed to this. mgh plus half mv squared equals to mgh plus half mv squared plus p. The initial velocity is 0 because it's only drop, the final height is 0, and the final velocity the same. So we replace these values in the formula. mgh plus 0 is equal to 0 plus 0 plus p. Finally, the total energy is the only initial potential energy and the loss of the energy at the end. So finally, we have mgh equals to P. This is our data. EP is the potential energy, EK is the kinetic energy, V is the velocity, M is the mass, that is 6.56 grams, G is the gravity, 9.81, and the height is 1.70 meters. And the P is the loss. Here we have our middle, loss from start to finish. This is from the tracker. Here we have the mass, that is 0.00656 kilograms, multiplying by the gravity, that is 9.81, multiplying by the height, that is 1.70, that it's equal to 0.083 joules. So now we calculate our bounds by bounds. In the tracker, we count 7 rebounds. So this is our first rebound. This is our formula. The only thing that changes the height at our first rebound. That is 0.84. So the P is equal to 0.0293. This is our second rebound. The only thing that changed is the height, that here is 0.48. So the P is 0.0232. This is our third rebound. The only thing that changes the height, that is 0.30. So the P is 0.0115. The other rebound is 0.0078. The other rebound is 0.0013. The other rebound is 0.0032. So this is our final rebound. The P is equal to 0.0032. Now that we have all the lows of the rebounds, we have to add all of them. We do that, and we obtain 0.0795 joules. This is different from what we got in the start. In the start, we got 0.083385, and here we have 0.0795. But there are some reasons why we have this. This is why the results are different. The energy lost by the ball bouncing in a vertical motion can be calculated by change in the potential energy. The results are almost the same, but there are some variables that can affect the bouncing. For example, when it hits the ground, that's some energy lost as sound. When it hits the ground, the act of deforming the surface along with frictions and compressing air all contribute to creating heat. That means some more energy is lost to heat. So this is important because now we know that are some variables that can affect our results. As we see, it was my experiment. I hope you like it. Thank you.